Okay, guys, so we are on our last chapter for the course, chapter 5.5, which is the fundamental theorem of calculus. And uh, this is simply numerical derivatives, numerical computations of the derivative integral of f of x between a and b for dx is equal to fb minus fa, where f uppercase F is the antiderivative of the function f. And all this is saying in a nutshell is that we're able to numerically compute the derivative by integrating and substituting values. So let's take several examples. This is from your homework. Integral of 6 dx. The way this is written is, so the integral of 6 is 6x, and this is integrated between 6 and 3. So what the fundamental theorem says, that we substitute 6 times 6 minus 6 times 3, which is 36 minus 18, or 18. I also want to make sure that you know how to do this with the calculator. So I'm going to go ahead and show you the process. If you're using the TI-84 plus CE, you would press the map button and scroll down until you see number 9. And it does this, and you can actually type in values to this. Type in, we're taking the integral of 6 with respect to x, and it will bring out the answer for you directly. So it's good to know this, okay? Good to know this information so you can actually use this to check your answer. Yeah? To verify that your answers are correct. Moving on. Question 2 is the integral between 4 and 1 of 7x dx. Let me just make sure this thing is recording. Sometimes I get hallucinations when I think I'm recording and nothing is recording, okay? So add 1 to the power, divide by 2 between 4 and 1. So it's making substitutions now. This is, 7 times 4 squared over 2 minus 7 times 1 squared over 2. So 4 squared is 16 times 7 is 112 over 2 minus 7 over 2, which is 105 over 2. Again, if you're doing this with the calculator, So math, number 9, 1, 4, 7, x dx, and ask the calculator for a fraction answer to give 105 over 2. Capture this, copy, and paste it. 1 second, please. I need to just pause this for a second. Okay, I'm back. All right, we're going to continue here. So we've got question 3. The integral between 1 and 5 of 8 over x, which is the integral of 8 times 5, 1 over x. And recall that the integral of 1 over x is ln x absolute, and this is between 5 and 1. So substituting, I have 8 ln 5 minus 8 ln 1, which is the logarithm ln 1 is equal to 0. So this is 8 ln 5. Don't attempt to put that in your calculator, because the calculator would actually give you a numerical answer. This is the exact answer. And MyMathLab would require you to put in the exact answer. Question 4. Integrate between 0 and 2 e to the power 2x dx. So recall that this integral is e to the power 2x divided by the integral of 2x, which is 2. So okay, e to the power u divided by u prime. So this is integrating between 2 and 0, which is substituting numbers here, e to the power 2 times 2 over 2 minus e to the power 2 times 0 over 2. So this is e to the power 4 over 2. Then e to the power 0 is 1, so 1 over 2. Question is calling for the decimal answer to this, to the nearest thousandths. Okay, so this is e to the power 4 minus 1 over 2. You put it into the calculator. E to the power minus e to the power 4. Make sure we put that in parentheses, right? E to the power 4 minus 1, close parenthesis, divided by 2, to give to 4 decimal places 26.7990. Let me check that back. Nearest thousand, sorry, 3 decimal places. So 26.799. Note that you could also try to put this into the calculator as a function, and I'm not sure if it would work. Let's see, number 9, between 0 and 4, the function is e to the power 2x dx. Okay, so I think I put in the wrong number here. Yeah, it's my bad. It's between 2 and 0, not 4 and 0. 0 and 2 e to the power 2x dx. And you get the same answer. I don't know if I can remove this one here. I guess I can't, right? Now I took everything out of there. All right, let me do it back. Math. Number 9, 0 to e to the power 2x dx. Okay. So again, great way to check your answer to see if it's correct. Yeah. All right, moving along here, we've got question 5, which is the integral between 2 and 1, 2x plus 3 dx. So integrating here, I have 2x squared over 2 plus 3x between 2 and 1, which is x squared plus 3x between 2 and 1. So substituting 2 squared plus 6 minus 1 squared plus 3, which is equal to 10 minus 4 or 6. Let's put that in our calculator and check it. One, 2, x squared plus 3x dx. Oh, crap, I'm integrating the wrong thing. I'm a mess. Here we go. 1 and 2, 2x plus 3, the original function. I'm integrating I was trying to integrate the integral before, which was not a good idea. So this gives you your answer. Actions, capture the screen, and copy it to the notes to verify your answer. And I know that some of you are going to be using your calculator for this. Just make sure that you know how to do the manual part of it, okay? Encouraging you to learn that part. Now, let's take a similar problem but we're going to flip the integral around, 6 and 2, put the larger number on the bottom and the smaller number at the top. So as you can probably expect, this is going to be a negative answer. So this is x squared. This is the same integral as the previous problem between 2 and 6. In other words, we're substituting 2 first. So that's 4 plus 6 minus 36 plus 18, which is 10 minus 54, or 44 negative. So again, calculator, we want to confirm this answer. Math number 9, between 6 into 2x plus 3 dx. To give your answer is negative 44. Integrating 5 between 3 and 5, 4x squared plus 9 dx is equal to 4x cubed over 3 plus 9x between 5 and 4. I kind of like to do things the old-fashioned way, so I'm going to substitute numbers here. So I have 4 times 3, 4 over 3 times 125 plus 9 times 5 minus 4 over 3 times 4 for 16, 16. 4 is this problem is not correct. I know something was wrong. This is 3. This is 3. 3 threes 9, 9 threes are 27, and then 9 times 3. So this is 500 over 3 plus 45, and then this part, 3 into 27 is 9, 9 fours are 36, plus 27, so minus 63. So this is 500 over 3. 45 minus 63 is 18. Minus 18. Okay, let's check that back. 8 and 5. 8 and 5 is 13. 4 and 5 and 1, 6. So this is 500 minus 18 times 3 is 54 over 3, which is equal to 446 over 3. And as usual, we want to go to our calculator and make sure that we run a check on this. Math number 9. And remember, in this case, to ask for a fraction answer, right? 3, 5, 4x squared plus 9 dx, math, fraction answer, to give 446 over 3. I think I copied the wrong thing. Of course I did. Where are the screen captures? All right, let's see if that copied correctly. Okay, there you go. We're moving along here. Question 8. Between 9 and 9, x squared minus 7x plus 4 to the 14 power. So as you can imagine, if we took the integral here, we're going both a and b is is the same. So this is from chapter 5.4. It says that the integral between a and a of f of x is dx is equal to 0. Okay, we don't need to do a calculation here. Question 9. Integrating 4 to 2, 2x minus 3 power minus 2 dx. So integrating here, we've got between 4 and 2, the integral is, what is it? Add 1 to the power. Let's do this as an integral here. Add 1 to the power. This is, and divide by negative 2. So 2x to the power negative 2 divided by negative 2 minus 2x between 4 and 2, which is negative 1 over x squared minus 2x between 4 and 2. Okay, now we're going to go ahead and substitute some numbers here. This is negative 1 over 4. 4 4 is 16, so negative 1 over 16 minus negative 2 times 4 is negative 8. Okay, then minus negative 1 over 4 minus 4. So this is negative 1 over 16 plus 1/4 minus 8 plus 4, which is negative 1 over 16 plus 1/4 minus 4. Okay, so we need to make everything the denominator 61. So this is 16. So this is negative 16 plus 4 over 16, and then 4 times 4, which is negative 16. Sorry, 16 times 4. That's negative 64 over 4 over 16. So this is 1 plus 4 minus 64 over 16, which is, what is that? 60. Sorry, this is negative 1. So this is negative 61 over 16. Negative 61 over 16. Let's see if that's correct. Clear this math 9 between 2 to 4 2x to the power -3 minus 2 dx. Math, fraction, answer. And we get -61 over 16. So I'm sure some of you are going to try to use your calculator for that instead of doing the work, right? Yeah, I'm just checking on you guys. 10. Integrating between 0 and 1 for 12. The 12th root of x dx. So remembering how to integrate here, this is 12 x to the power 1 over 12. X to the power 1 over 12 dx, which is 12 times x, taking away 1 from, adding 1 to 1 over 12, we get 13 over 12 divided by 13 over 12. Between 1 and 0. So this is 144x to the power 13 over 12 divided by 13 between 1 and 0. Easy computation here. Substituting 1, we get 144 over 13. And substituting 0, we get 0. So if we're subtracting 0, our answer is 144 over 13. You guys want me to do the calculator, don't you? So math, number 9, integrating 0 to 1, 12, math, 5, oops, that's completely wrong. Math, number 9, 0 to 1. I'm just going to take this as a power, right? 12x to the power 1 divide 12. Dx, math, fraction, answer. Waiting on the answer here. Oops, this didn't come out. So math, fraction. Yeah, we're not going to get a fraction answer out of this, so you're going to have to actually work. Let me just try one more thing here. Math, 9, 0, 1, 12, open parenthesis, math, number 5, 12, x dx, math, fraction. Okay, so the calculator is unable to compute this. Calculator cannot compute as a fraction for this problem. In other words, you're actually going to have to know how to do the problem, okay? All right, moving right along. Number 11, 1 and 0, 7x x squared minus 1 to the 14th power dx. So this is the substitution, u substitution here. In order to get, if we take u is equal to x squared minus 1, u prime is equal to 2x. Instead, we've got a 7x here. So we need to convert it to a 2x. And the way you would do that is bring 7 outside. Then take, in order to get 2x here, we're going to have to divide by 2. That means this would be 7 over 2. X squared minus 1 to the 14th power dx. Okay, so now you can see that that we have what we need here, okay? Where this is u, and this is u prime. So the integral then is 7 over 2 x squared minus 1 to the power 15 divided by 15. Add 1 to the power and divide, which is 7x squared minus 1 over 30 to the power 15. And we're doing this between 1 and 0. So substituting, we've got not a bad substitution here. This is 7 into 25. I'm a little lost here. Okay, yeah. Substituting 1 here. So this is 1 minus 1 to the 5th power over 30 minus 7. Anything to the 0 power is equal to 1. So this is 1 minus x squared. So x to the 0 power something is not working out here. Let's see. This is 7 over 30. 1 let me look back at this. This is minus 7. Why is this coming out? 1 to the 0 power is 1 minus 1 to the 15 power over 30. Hold on, I'm going to pause this for a second and look back at this problem. I'm just having a... Okay, I'm back and I can see where I made a mistake here. This is not 1 minus 1, but 0 squared minus 1. So this first, because this part here is equal to 0, this one is equal, that whole part is equal to 0, minus, and then I have 7 times negative 1 to the 15 power over 30. So this is minus negative 7 over 30, which is positive 7 over 30. I am not sure at all if the calculator would solve this for you. I can try it and see. Let's do a check here. Math 9 0 1. Now you're going to have to be very careful how you use your parentheses here. This is 7x, open parenthesis, x squared minus 1, close your parenthesis, to the power 14 dx. And let's ask the calculator for a fraction answer, and see what it gives us. If we're lucky, we will get the answer here. Notice how long the calculator is taking, and wow, it did it for us. So not bad, not bad at all. You guys have the calculator solution there to confirm our answer. Okay. Question 12 looks like this. 37 to 35 x into x squared minus 1225 dx. So we want to start by saying this is integrating between 37 and 35 of x into x squared minus 1225 to the power half dx. Notice that if u is equal to x squared minus 1225, u prime is equal to 2x. So we have to manufacture a 2x here. So this is 1 over 2, 37 over 35, 2x, x squared minus 1225 to power half dx. And now we can integrate. Okay, this is u prime and this is u. So this is half x squared minus 1225 to the power 3 over 2 divided by 3 over 2. I've got one too many 2's here, right? This is 1, 2, 2. So flipping over and multiplying, this becomes x squared minus 1225 to the power 3 over 2 over 3. The 2's are going to cancel out. And all of this between 37 and 35. Fix that. So this is I went to the calculator for this part, x squared minus 1225 over 3, because I had made my substitution. This is let's see, x squared, so 35 squared minus 37 squared minus 1225 gives 144, and then we're going to take that to the power 3 divide 2 to give 1728. So this is 1728 over 3. And then x squared minus 0, this is substituting 35 in there, we get 1225 minus 1225 over 3, which is answer 1728 over 3, because this is 0. I think that divides exactly, doesn't it? Yeah, 576. 576. All right, let's see if the calculator can produce an answer here for us. So math, integrating 35, 37, x into x squared minus 1225 to the power half dx. It may or may not work. Let's see. So we get an answer 576.0003, which is acceptable. Very acceptable answer. Okay. Question 13. Integrate between 3 and 1, x minus 2 over x squared minus 4x plus 6 dx. So lots of manufacturing happening here. U is equal to x squared minus 4x plus 17. U prime is equal to 2x minus 4. Consider that this is 2 into x minus 2. Now, we already have the x minus 2 part here, so we need to just manufacture a half to cater for that. Now, be very careful here because you're integrating 1 over u, okay? You're integrating half 3 over 1, 1 over u, du, which we know that the integral is ln u times the ln u, sorry, the integral is ln u. So half ln x squared minus 4x plus 6. Okay, this is the integral of ln u over, sorry, I forgot to mention. Let me just give you back the integral here. The integral of 1 over u du is equal to u prime over u du. And this is equal to ln u. Okay, so this is between 3 and 1. Half. Substituting 3, we get 9 minus 12 plus 6 minus, oh crap, I forgot the logarithm, half ln 1 minus 4 plus 6. Substituting 1. So this is half ln 3 minus half ln 3, which is equal to 0. Again, you're more than welcome to try to see if the calculator would give you a solution for this. Maybe it will, maybe it wouldn't. I don't know. Calculators are funny with these types of problems. So 1, 3, use the fraction bar here. I've got x minus 2 divided by x squared minus 4x plus 6. The x and press the enter button. And yep, the calculator does work for this one. Capture the screen, copy, and we can say that we confirm the answer as 0. All right, question 14. I'm going to have to write this problem out for you and then attempt to work it. It says the 2000 census gives the age distribution in millions by the function f of x equals to 39.6 plus 2.09x minus 0.882x squared. A, find the integral over zero to 9 and say what the integral represents. What does it mean? So considering what's happening here, if we integrate, we're integrating between 9 and 0 of 39.6 plus 2.09x minus 882x squared dx. And for this, I'm not going to integrate it manually. I'm going to put it directly into the calculator. Okay. So math number 9, integrating between 0 to 9, I've got 39.6 plus 2.09 x minus 0.882 x squared x squared dx. And the answer would have to be in the nearest whole number, okay, because we're, the nearest whole number, which is 227. So let's put that screen in to show you guys how I got that answer. So this is equal to 227. The meaning, this means that the total number of people in this area aged 0 to 9 was 227 million in the year 2000. The second part of the question is asking find the number of people alive in 2000 born in the 80s. Great year for music. All right, that is in the range 1 to 2 decades in 2000. In other words, their age in 2000 would be between lost my train of thoughts there, between 1 to 2 decades. So all we're doing here is integrating between 1 and 2, 39.6 plus 2.09x minus 88.882. (0.882x squared with respect to x. Calculator. So now we're going for 1 and what are we going here? 1 and 2 and 1. So math, same function, but 2 to 1 instead. 1, 2, 39.6 plus 2.09x minus 0.882x squared dx. And ask the calculator for an answer here. We get 40. So it's approximately 40. Here's capture this. Approximately equal to 40 to the nearest year. Million. Okay, I forgot to put in the million here, 227 million. All right, one final problem. Given the demand function P is equal to dx is equal to 1000 over x, find the average price in dollars over the demand interval 500 to 800. So the very first thing you want to do is set up the integral here. Okay. Setting up the integral would be average price equals to 1 over 800 minus 500. Okay. The average price between 500 to 800, and then the integral between 800, 500 over the function into the function 1 over x dx. Okay, since we're taking the average price, we're dividing this function here by 800 minus 500 or 300. Remember, the average is the total number divided by the quantity. So this here is a quantity. Okay, average is total or sum total of n divided by n. Okay, so that's our equation that we're looking at now. All we have to do to find that average price is to integrate. So this is the first part. They're going to ask you to see the setup for this, and then going further here, this is 1 over 300 times 1000, or perhaps we can just take that. Actually, we can just go ahead and distribute the 300 and say this is 800, 500. I'm trying to see how I can make this as easy as possible. 1000 over 300 times 1 over x dx, which is integrating 800, 500, 10 over 3x dx. Now, to finish up the problem here, so when you're typing, this is the setup. Definite integral. My MATLAB is going to ask you for that setup. Okay, that's the setup for the definite integral. And then you just use your calculator to do the computation for you. So integrating here between 0 and 500, so math, 9, between 800 and 500, 500, 800, 10 divided by 3x. And I think I've got something. Yep, yeah, I input this incorrectly. I'm sorry. This is math 9, 500, 800. Use the fraction bar here because if not, you're going to get an incorrect answer. This is 10 over 3x dx, or use parentheses instead. So this is 1.57 to 2 decimal places, which is the correct answer. So 1.57, what is the unit here? Average price $1.57. Okay. All right, let's stop this.